Greetings and welcome. This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In today's session, we will be learning about the problems on centroid of simple and composite sections. The course outcome of today's topic would be identify the centroid and center of gravity for the simple and composite plane sections from the first principles. The topic covered would be problems on centroid of simple and composite sections. The topic learning outcome is understand the concept of centroid and center of gravity involved in practical engineering problems. So before going to the problems that are related to the centroids, just we will be recollecting the data, how the procedure for this application of centroid equation can be taken. We need to concentrate that for a complex sections, that is the sections which involves two or more shapes, the standard shapes that will be divided to the regular shapes, and then we will be finding out the centroid of each individual part, and then we will make the sum of the total centroids by using the formula we have for the centroid, and we will be obtaining the result. So that would be the procedure for obtaining the centroid for any given complicated section. Let us first see the problem given. Find the centroid of plane lamina shown in figure. This is the figure given. So this is the shape of the L, right? This is called as the L-shaped lamina. Okay. So as the first step, what we need to do is first we need to finalize the axis, the reference axis for obtaining the solution. So the reference axis for this particular problem which is given is taken from the base of the lamina as x-axis and the side of the lamina like this as y-axis. So these axes would be the reference axis for our problem. We need to keep it in mind that these reference axes can be taken according to our convenience. The simple way how we can identify the solution, we can observe that, and the reference axis can be taken. We can also take the axis in reverse way also. Like we can place the x-axis at the top of the object and the y-axis at the right side of the object, which will yield to the negative values of the problem. So that this 20 centimeters, let us say, to be considered as minus 20 centimeter from the y-axis. So in this way, the quadrants will be manipulated with respect to the reference axis which we consider. So the easy way to calculate this type of problems, or according to the given section, the easy way to find the solution, what we do is we will be considering the x-axis from the base of the object and y-axis from the left edge of the object, so that the values can be treated as positive. Like this object is placed in a first quadrant. Okay, so after considering this reference axis, the second step would be dividing this complex object. See, directly we do not have a particular formula for obtaining the centroid of this type of sections. So what we need to do, we can divide this given complicated section into number of parts which are of regular shapes. Okay, here as we are seeing, we can divide this L-shaped section into two rectangles. Either we may divide this shape here like this, so that this is the part 1 and this is the part 2, two rectangles, or else what we can do, we can divide this section or divide this given lamina here, so that this would be your first rectangle and this would be your second rectangle. After dividing this type of regular shapes division, then we can calculate the values of centroid for first rectangle and then the second rectangle. So how we can obtain the centroid of this first rectangle? The size of the rectangle should be identified first. Okay, so the total length of this rectangle can be obtained as 10 plus 20 centimeter. isn't it? Where 10 is the size of this thing and 20 is the size of this thing. So overall it will be value of 30 centimeters. And height of this rectangle can be obtained as 15 centimeters. That is given. Right? So from this we can calculate the areas. A1. Isn't it? The value of the area, the first rectangle's area can be obtained as length into breadth. Right? So that can be taken as length as 30 into breadth as 50. So overall it will be obtaining as 450 centimeters square. Similarly, we can do the position of the centroid here. So we know that the position of the centroid for this rectangle is at the diagonals intersection, we can say. Let us say it is at the center here. Right? From x-axis, what distance the centroid would be? As it is given as 15 centimeters of total height, we can say that the centroid would be 7.5 centimeters from the x-axis. So this value would be y-coordinate. Coming to the x-coordinate, how much distance this would be? It is exactly at the center of this total length. So that length is given as 30. So this distance would be 15 centimeters from the y-axis. So that would be the x-coordinate. So with this, we can identify the distances of centroid as x-coordinate is 15 centimeter and y-coordinate as 7.5 centimeter. So the centroid's first rectangle's centroid is at the position of 15 and 7.5. So for this representation, we can take it as x1 and y1, where x1 is the distance of the centroid from the y-axis for the first rectangle, and y1 is the distance of the centroid from the x-axis for the first rectangle. So all these calculations or all these representations which we have made here is for first rectangle. Now we have to consider the second rectangle, where for the second rectangle, the size should be considered first. So the length of this rectangle is given as 10 centimeter, whereas the height here from top it is given as 30 centimeter. So the size is 30 centimeter, 10 by 30 centimeter, 10 by 30 centimeter. So overall length here, this length is given as 30 and this length is given as 10. So area. Now, if I am finding the area of second rectangle, second division, we can obtain it as A2 is equal to, again, length into breadth. So we can write it as 10 into 30. So that would be 300 centimeters square. So that is the area of that second rectangle. Coming to the position of the centroid. Let me erase this. Position of the centroid which we are considering. Here you can see we have divided this object at this condition, and this is your y-axis. This is your y-axis. So again the centroid would be intersection of the diagonals, right? So this would be at the center position here, and the value for this thing can be written as 15 centimeters. And from y-axis, let us say we have to consider for this rectangle alone. Now we are considering for this rectangle alone. Okay. So again, this would be your 15 centimeter. The centroid of this particular section alone we are considering. Coming to this distance. This distance would be 5 centimeters. As the total distance is 10 centimeter, we can consider that distance as 5 centimeters. Now, the centroid of this second rectangle with respect to the reference axis, we need to consider. That is very, very important here. Okay, this is not the exact position of the centroid with reference to reference axis. Okay, the centroid should be considered from the reference axis. Considering that particular individual object alone, we can say that the centroid will be at 15 centimeter and 5 centimeter. But this is not when considering the total object, this is not the case. So what we need to do, we need to find the centroid of this particular second rectangle with respect to the reference axis which we have considered. So for that, the distance of the centroid with respect to x-axis which we have considered, that is base of the object, what we need to take the length as, already this is at a distance of 10 centimeter, and then further it is at a distance of 15 centimeter. So overall, from the x-axis, the distance of second rectangle centroid is 25 centimeters. So this would be your y2, because it is the distance from the reference x-axis. Then coming to the x distance, from the y-axis, this centroid is at a distance of 5 centimeters from the y-axis itself. So this x2, the distance of centroid from y-axis, which is x2, is 5 centimeters. Okay, in that way, the value of x2 and y2 would be 5, 25 centimeters. So this is the centroid distance from the reference axis. Now we have obtained the values of areas of both the individual rectangles and then the centroids of both the individual rectangles with respect to the reference axis. Now directly we can apply the centroid formula used in the simple, and substituting these values in the centroid formula, you will get the complete complex sections centroid. So that we will see now. So the procedure how to solve this problem is given like this. We are first dividing the given complex lamina into part 1 and 2, and the centroids of this lamina, individual sections, individual rectangles, is being considered like this, and the values of x1, x2 and y1, y2 is considered as shown in the figure. So after obtaining sequentially the values of areas and the values of the centroids of individual rectangles, we will be substituting the values like this. Divide the composite section into two rectangles, and now consider the rectangle 1. For that, the area A1 can be obtained as 30 into 15, that is equal to 450 centimeters square, and the value of centroid for that particular individual rectangle 1 is given as 15, 7.5 centimeters. And for rectangle 2, we can get the value of area A2 as 30 into 10, that is equal to 300 centimeters square, and G2 is equal to 5, 30 centimeters. That is the centroid of the second rectangle from the reference axis. Then the position of centroid from OY, that is the x distance, that is from y-axis reference, the position of centroid from OY, we are going to apply the formula x bar is equal to a1x1 plus a2x2 by a1 plus a2. From this we can write 450 into 15. We are just substituting the values of a1x1 and a2x2 here. A1 is 450 into x1 is 15 plus 300 into 5 by 450 plus 300, that is equal to 11 centimeters. Then position of centroid from OX, that is from x-axis, the base axis, the value would be y bar, that can be obtained as a1 y1 plus a2 y2 by a1 plus a2, that is equal to 450 into 7.5 plus 300 into 30 by 450 plus 300, that is equal to 16.5 centimeters. Thus, we have obtained the center of gravity or centroid of the complex lamina, that is L-shaped lamina. Now with this you can observe here that the x bar, that is distance of centroid from y-axis, and y bar, that is distance of centroid from x-axis. Let us say this is the y-axis which we have considered, and this is the x-axis which we have considered. Now the distances, if we consider from y-axis, it is at a distance of 11 centimeters on this line, 11 centimeter line, let us say, and from y-axis it is a distance of 16.5. 16.5 is somewhere here. So the centroid is lying away from the object. You can see there is no material present here, but the centroid of given L section is lying away from the object. This is the centroid of the given section. That is the small observation which we have already discussed in the introduction of centroid topic. So this is the value of centroid for the given L-shaped section. Now let us go to the another problem. Find the centroid of composite lamina shown in figure. This is the figure given, and we need to identify the centroid for this complex lamina. Here the axes are given in the problem itself. Okay, so this is the x-axis which is at the base of the object, and this is y-axis which is at the edge of the object, and this is the origin to be considered, and the length or size of the given data, size of the values that is given here is height of the rectangle is 125 and length of the rectangle is 200 given here, and there is a small portion of semicircle that is being cut. Okay, the shaded region here implies that there is the material present here, and this hollow section, the semicircle shape is representing that there is no material present here. There is no material present here, and the diameter of the semicircle is given as 75. So with this we can understand that there are with this complex shape of the lamina, we can divide this complex shape of lamina into two, where a semicircle has been removed or a semicircle has been cut off from the regular rectangle. So this complex shape can be divided into two regular shapes, that is one regular rectangle and another one is the semicircle. So for this sort of complex lamina, how the problem we are considering. In the previous problem, there are the materials present and there are the two individual sections, two individual rectangles. They are the additions. That means for completing the lamina, we have added the individual rectangles data. Here, the semicircle data should be subtracted from the rectangle data, because the second regular shape of semicircle which we have considered, it is hollow, that is material is not present. So what we will do, we will be subtracting the data of this semicircle from the regular rectangle data. So how to do, the procedure, everything what we have considered is same. First we will be identifying the centroids of individual rectangle and individual semicircle, and then we will be applying the values in the centroid formula. So if we try to identify the centroids of the given system or given section, here the procedure is shown. If you observe, the centroid of this rectangle is positioned here. For the rectangle, it would be at a distance of x1 from the y-axis and at a distance of y1 from the x-axis. Coming to this semicircle, the centroid would be lying here. Okay, and we do have the as this is a symmetric about this axis, we can say that from this edge, from this corner, this distance would be the radius, right? So this distance, let us say this from the y-axis, we can add the complete distance here so that we can get the value of the centroid from the y-axis. As this is to complete length is given as 200, or else we can subtract this radius. Already the diameter is given as 75, so 37.5 can be subtracted from this 200 so that we can get the value of the position of this centroid of semicircle from the y-axis, that is OY. Similarly, the distance of the centroid of this semicircle with respect to x-axis, this position, x-axis, how to obtain that? We do have the formula that y, the representation of the distance would be y2, that as 4r plus 3y. So that is the distance of the centroid for the semicircle that we have already seen in the formula. When you substitute the values in the formula, then you will get the answer. So now let us start the problem. Divide the given section into rectangle and semicircle. Then A1, or the area of rectangle 1, can be obtained as 200 into 125, that is 25,000 millimeters square. Then the centroid's position of this rectangle would be 100, 62.5 millimeters. That would be the distances of the centroid from the x-axis and y-axis. Then area 2, that is the area of the semicircle, is pi r square by 2. So that can be obtained as pi into 37.5 square by 2. When you solve this, we will get the value as 2208.93 millimeters square. And the position of the centroid will be evaluated as 162.5, 15.91 millimeters. So these are the x2 and y2 values of the given semicircle. Then the position of centroid from OY of the total figure can be obtained as x bar is equal to a1 x1 minus a2 x2 by a1 minus a2. That can be obtained as 25,000 into 100 minus 2208.93 into 162.5 divided by 25,000 minus 2208.93. So if you further simplify that, you will get the value of the x bar as 93.94 millimeter. Then the position of centroid from OX, that is x-axis, base axis, the centroid value would be y bar. The equation would be a1 y1 minus a2 by 2 by a1 minus a2. When you substitute the values, it would be 25,000 into 62.5 minus 2208.93 into 15.91 by 22791.07. When you further simplify this, you will get the value as 67.01 millimeter. So the coordinates of the centroid E is given as x bar is equal to 93.94 millimeter and y bar is equal to 67.01 millimeter. So in this way, when there is no material present in the given lamina, then we need to subtract the data, the hollowness of the regular shapes from the material that is present. In this way, we will be calculating the values and coordinates of the centroid. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.